Today's webinar will go through and showcase the Forsidi SecurityCAD tool and show you hands-on how to get started. This will be done by Henrik Hellbro, Forsidi's lead on Azure, together with Andreas Gylling, the lead developer of the Azure implementation. But we're excited to also be joined by Mattias Sköld-Strandberg from TRR, who is our beta customer that we've worked very closely with in the development. We have already since onboarded a number of customers, so the product is product grade ready. Mattias Sköld-Strandberg is lead architect at TRR. Mattias is central in TRR's ambition for digital transformation to cloud and has worked closely together with the Forsidi team in the development of support for Azure in SecurityCAD Enterprise. Mattias will join to offer his reflections and innovative perspective, but also offer useful tips and tricks of his hands-on experience with Forsidi SecurityCAD in Azure. TRR is a linchpin of the Swedish labor market as an industry organization for 35,000 private sector employers and 950,000 employees throughout Sweden. TRR supports redundant employees before, during, and after transition to alleviate for the individual with a goal for a path from one job to another to be as short and efficient and meaningful as possible, to help both as a result of short-term changes to more structural changes. The format of this webinar is such that it will be an interactive discussion led by Henrik and where Andreas will give insights from development. Mattias will give his insights from customer perspective and TRR's experiences from using the product for a while. It's an interactive session in which the team will field your questions that you can raise to me as a moderator via the chat. I will then raise the questions to try to get them answered for you. At the end of the session, we will have time for questions. During the session, we will also conduct a few poll questions. But I think everyone's eager to get started, so let's jump in. And I'll hand over to you, Henrik.
Must unmute, Henrik.
Thank you, Anders, and welcome everybody. I will continue to showcase the Azure implementation, and I'll just switch the screen here. So here we have a simple schematic diagram which shows an Azure architecture where you can't really see the associations between different resources and services. This is where SecurityCAD comes into play. Forsidi provides a powerful tool for showing how different services communicate and how they're linked together. Once we have the model in SecurityCAD Enterprise, we can then continue to simulate how an attacker would traverse the architecture in order to reach a predefined high-value asset. SecurityCAD Enterprise is also a very powerful tool when you want to get a better understanding of your architecture than what your average Visio diagrams provide. You can also go ahead and use SecurityCAD to discover potential configuration mistakes or other possibly crucial errors that could have high negative impact on your infrastructure. We have support for Amazon Web Services as well as on-premise infrastructure, but for the sake of today's topic, we'll take a look at the Azure implementation. So let's dive into some details here. I'll just get rid of this. Yeah, for the sake of this demo, I thought that we would start out by looking at the Microsoft Azure portal, which you are all probably very familiar with, showing the resource groups. We can see that we have a couple of here. And for the sake of this demo, we've chosen to analyze 4 of them. We've chosen the back office, the container registry, the customer resource group, and the MC container registry group. But I will head into the back office, and the console will show us the different resources. As you all very familiar with, we can see the resources that this resource group contains. The problem that we know and we all suffer from is that we don't really see any associations here. We don't see how they're connected to each other. There's no real overview, and this is where the power of SecureCAD Enterprise really comes into play. The real power of SecureCAD is that we can read your Azure environment and contextualize, which means we capture information and visualize how the resources are connected. So I will head into SecureCAD. So SecureCAD has now generated the environment. Every little detail has been parsed. Let's see here. I just need to move my window. And a digital twin has been created. Now we have one model here, but there would be a list if you have many, and if you have them automatically generated, there would be a list here with lots of them. But for the sake of this demo, we'll just head into this one. I will head into the model. All right, so here we see the generated model, and to the left, wow, here we have the actual model, how it looks, and with the attacker placed on top. I will go through the UI just a little bit here. On the left, we see the view section. Sorry,
but that's a model that's been generated by SecureCAD to reflect that schematic that you showed and the console, right?
Yeah, correct. This is basically auto-generated, and we've converted that into a proprietary SecureCAD format that is then uploaded into SecureCAD, and then we can take a look at it visually here in the platform. So exactly, Anders, thank you for that. So just going through the UI a little bit, we have the usual open and save icons. We have the views segment, which is particularly good when you have a large environment that you can then split up into smaller views that would then be easier to analyze. Below that, we have the objects, which basically contain the different services and resources in Azure that we currently support in the Azure language. Yeah, so going back to the model then, if we take a look at the model, we can see that we have the attacker placed on top here. The attacker is placed in this position per default, but can be moved around and placed within the architecture, within a resource group, for instance, in order to simulate an attack coming from within. I'll just try to reposition here a little bit. Yeah, so the attacker, and the attacker is connected to, as a default setting, connected to outward-facing resources and services, interfaces, and other things. Yeah, so basically we have from top to bottom, we have the attacker, we have a couple of firewalls and account containers, we have roles, we have the subscription itself here, and below that we have a couple of resource groups, the ones that I showed you in the Azure portal before. So here we can really quite fast see that we have a number of associations going between different resources in the Azure environment, and we can quite fast see that this is more complex, and there's more to it than we saw in the portal itself. So expanding one of these resource groups, I will just move it out here, and I will zoom out a little bit. We can see that we have there's quite a lot of connections here. We can see that we have a database, we have interfaces, we have subnets, we have a lot of things in here, virtual machines and storage accounts, and a number of different resources and services that are within this resource group, and we can see how they are connected to each other. So if we take a look at, for instance, this VM here, we can show hidden associations. And in an instant, we can see that there are a number of things here connected to this VM. We have disks, we have credentials, and other things as well. If we take a look at, for instance, the key vault here, we open this. We can see that we have certificates, and we have a number of things connected to this specific resource or this service. And they can then be selected as high-value assets. In this case, we have a number of high-value assets that are marked in yellow. For instance, this database, this VM, we have a number of other things here. We have a row in a Cassandra table within a database. And we have a Kubernetes cluster that is also set as a high-value asset. As a side note, having this architecture that is the digital twin of the architecture that you have, we can also use the different objects here in the object canvas or in the selector here, and we can drag these in and essentially connect them to our infrastructure in this digital twin, and re-simulate and get an understanding of where we are in terms of risk exposure without even having to deploy it live in Azure. So we can basically take our current situation, add components, services, and connections, associations, and then we can simulate this and get an understanding of where we are in terms of risk. This means that you can, So regarding service principles, maybe Andreas, you can share some light on that.
Oh, sure. So if you zoom in a little bit on the attacker again, or that specific area, so a little bit more clearly, I just want to go through a couple of things here that might not be translated directly in Azure. So the concepts of this service principal container and account containers, they're just a collection of all the principles that we found within your environment. So that means that we're not really actually reading directly from the Azure Active Directory and all the users there with its sensitive information, but we rather create them implicitly by the role assignments that we found for this particular environment. So what we see in a role assignment is that it has an attached principal ID and a principal type. So if we find, for example, a principal type of AD user, then we know that it's a valid account within your environment with this ID, but we don't really know who or specific emails or whatever. But this means that we only really get the accounts that are of interest for this environment. So what the attacker really does here is that it's trying to get access to any of the credentials of either a service principal or an AD user within this environment to assume that principal and start using his privileges. Now, another thing that we could probably go through, Henrik, is opening up one of these assets and how you set them as a high-value asset. So the concept of the high-value asset is your business critical components, basically. So Henrik, you can go ahead and go into any of the Cassandra key space. It doesn't really matter.
I'll take. Is there a specific one that you want me to use? This one, maybe?
Yeah, we can take a look at that.
Yeah.
So you enter preferences, and then you have a list here of attack steps. Now, if you were to extend one of these attack steps, so the way that you set a high-value asset is by adding a consequence value between 1 and 10. The value of it doesn't really matter in terms of the results of the attack vector or the logic, the critical path that you're going to see later. The path that the attacker took to reach this end goal will not change, but the value that you set will help you focus your resources on the most critical parts of your environment first. So if you have something that is really critical, then you should set a value of 10. Then you have the concept of local TTC, where if you're interested in probability, you can set your own cumulative distribution function, which the simulation will sample from if you think that this attack step should follow a specific curve. But the most common one is probably if you click on this local TTC, Henrik, is if you consider a specific attack step this shouldn't be reachable from an attacker. We deem that this is pretty secure, and we don't want this as part of the attack vector in our critical path later. Then you could set infinity. So those are the SecureCAD default and infinity are probably the ones that you're going to play around with the most. So that's what I wanted to say about high-value assets. You have the concept of defense as well. So if you double-click on a virtual machine scale set or something, we should have a defense in there, I think so. And yeah, exactly. So on the bottom there, you have defenses instead. And what they are ways of stopping the attacker in its path for reaching specific attack steps. So and here you set the probability value between 0 and 1, where 1 means that it's going to be active 100% of the times of all samples in the simulation, and anything in between is just, well, 0.5 means 50%, 0 means it's always off. And this is basically the same thing as setting an infinity local TTC on a specific attack step. It stops the attacker right there and then. And yeah, I believe those are the technical concepts that I want to address.
All right, so to summarize, SecureCAD visualizes and shows association sections that really can't be seen in the Azure portal.
Yeah, so a comment from TRR. This was really an eye-opener for us in a sense that we saw the connections and the resources and things like that, which as you probably know, in Portal, it's not that nice feeling. So this gave us a picture and our environment looks like. A great upside with the SecureCAD is that we can change the model, as Henrik showed before, and see the consequences before we actually do the changes, which is a really, really nice feature. And also how the Azure identities works in the sense. We do not want our applications to have passwords and things like that. So we go for as high up we can, which means that we use these managed identities, which is in this case the suggested mitigations for account problems that may occur.
Yeah, thanks, Matthias. Thanks, Matthias. We have a question that has come in here. Which services are supported?
Right. So I'm probably going to miss some here, but to list a few of them is we have support for the Azure database for Postgres, MySQL, MariaDB, and the Cosmos DB. So a lot of the database services, VMs, virtual networks, key vaults, storage accounts. And as of late, we also added support for API management, Kubernetes, as well as container registry. And then we have another feature, or we support application insights, which we can use to enhance the model even further. So when you want application level data or communication, which we cannot really read from the configurations of our Azure environment, we can make use of the application map of application insights and then see that there is a connection string between this app service, which we also support, the function app or a database. And this helps us create these associations without having to read the application level code. Now, this can be further improved by also adding vulnerability data, which SecureCAD supports. But yeah, all of the supported services are listed in our GitHub repo, which you can read more there.
Great, thanks. So I will now continue to take a look at the environment. Now that we have the environment processed and scanned in as a digital twin, we're ready to analyze and let the AI do its magic. So basically, we just select the model that we want to have simulated or scanned, And then we just press start scenario, which would then essentially just start the simulation and running the simulations with the AI simulations with thousands of Monte Carlo simulations to mimic how an attacker would would traverse our environment, which would take a couple of minutes. So we have prepared that for you. When the simulation is done, we get a report, and the report is looks like this. We can see that we have a total risk exposure of 55% in this case. Scrolling down, we see our high value assets and how SecureCAD has used these simulations in order to create attack paths or critical paths. A few of we will take a look at right now. So let's dive into this and take a look at we'll take a look at the first one, which is this row delete path, and I've prepared that for you as well. All right, so here we see the critical paths that the attacker could take in order to reach this row delete method and the high value asset that we've defined or predefined that you also saw in the model that we've highlighted in yellow. Here we have the entire structure. If we decrease the detail level some, we get a condensed view of how the attacker most likely would approach this high value asset, and we can see that there are a number of paths here. So Andreas, could you please just walk us through this?
And before, just curious, why are there two paths?
Right, good question. So the end goal here is that you want to reach row delete, or the attacker wants to reach that. That's the high value asset, and there are two paths because there are several prerequisites that needs to be fulfilled in order to reach this end goal. And in terms of Cosmos DB, this involves first that the request of a data operation needs to come from a valid endpoint, meaning that it's determined by the networking section of that resource. And secondly, you need access to this read-write URL, which allows you to perform these operations. And if we begin by that path, the first condition, meaning the URL, that's built up by a connection string of the Cosmos DB, which is obtained by just listing the keys of that resource. So if you continue to the left, Henrik, you can see that the attacker will begin by trying to get a hold of any Azure account in our environment and steals his credentials. And once he's done that, he can assume that principal attached to that account, which in this case has the permission of listing the Cosmos DB keys. So that is step one. But he needs to use this URL on a valid endpoint, as I said. So if you continue a little bit back to the right again, we can see from the firewall here that requests coming from the back office subnet are permitted. And the underlying back office VM areas within this subnet. So if the attacker can get a hold of this VM and perform the request in there, then it's fine. And he can do so by seeing that for this virtual machine, there's an open SSH port, which means that the attacker can exploit that. And in the same way there, gain access to the credentials here will give him high privilege access to the VM. So the attacker has reached both the conditions in order to delete this row. Is on the valid endpoint, and he has access to this read-write URL through this service principal or account, sorry.
And Andreas, just for clarification, I think people might be wondering, there are a couple of symbols there, a question mark and triangles. What do those signify? Yeah,
so the question mark are the intermediate assets that are involved in order to reach this attack steps after transmit request from the attacker network interface. And in this case, we see that it's the back office VM network security group, which tells us that, okay, this is the network security group controlling which ports are open and the communication that is allowed. And for the triangles, that's the concept of the defenses that I spoke about in the web modeler. If you activate any of these defenses, you will stop the attacker right there and then, and it cannot continue further than that. And we have the same for the account in this case, which, as I said, we're reading implicit accounts, which means that we can't really tell if it has multi-factor authentication. Oh no, sorry, this is a service principal. In this case, we can change the service principal, which has just a ID and a password or a secret. Azure suggests that you use managed identities instead, and then you don't have the risk of leaking this secret to the attacker, or he can get it through any other means. But yeah, so the defenses and the intermediate assets are the answer to the question.
Okay, so the conclusion then is that the significance of this is that you can show that there are multiple prereqs that are needed.
Yes, correct.
So this was exactly the combinations that is crucial and significant for TRR, which we have a complex scenario or complex environment. So this will actually condense it down to see the most possible path, which we can focus on to stop the attacker.
Okay, thanks, Matthias. Thanks, Andreas. We have another example that we wanted to show you, which is basically this attack step number 15 here. A critical path that shows a writes scenario, and here we have that attack path in the same way we did before. So maybe Andreas, you could walk us through this one as well.
Yeah, sure. So a couple of new things that we see here. It's a little bit more of the same, but now we actually also have the concept of the account container being involved and not just a service principal. And in the same way there, the attacker tries to get access to its credentials and assuming those principals connected to that account. And in this case, what I wanted to say before is that as we read them implicitly, we do not know if they have multi-factor authentication enabled or not. So that's something you can define yourself in your scenario, which you can use for each simulation, so you know which ones actually have that enabled or not. But as for the rest of the critical path here, we have also the concept of inheritance. We see that we have a couple of principles here that have write access to the subscription, which in turn gives write access to the resource group, and every underlying resource there then gets the principal itself can then write to that resource. And you also have specific write access permission to the resource group itself. So it doesn't really matter that basically you have two different permissions to get direct write access. And then you also have a PREVESC technique or privilege escalation with the shared access signatures. We have that you see on the top there, the top middle play button or whatever you want to call it, the storage set SAS. What that means is that an attacker can use shared access signatures if they assume any of these principles and give himself any sort of permissions that he wants on this storage account for a set time, which he can put whatever. And that essentially means that, well, he's delegating himself any privileges, which is just root access. And getting root access is also possible through the access key of the storage account, which in this case, we see that we have a firewall that is open. It doesn't restrict any access. And then we also include the scenario of this key being leaked and that the attacker can then get root access by authenticating himself with this key.
Yeah, I was thinking this is really interesting. If you look at the TRRs, if I just compare it to the TRR's complex environment and how some of the strategic movements we have taken, like going for Azure, and we have an CI/CD pipelines and things like that. So this is actually a real good complement for our, how should I say, ensure that things are working as they should. So we try to aim as high up in the tech stack as we can, meaning that some of the VMs still need to be there for financial systems or whatever it may be, but we try to get as high up as you can. And by using the CI/CD and the how should I say, the infrastructure by code that you can use by Azure, we can actually combine these different parts and having quality gate to run the security CAD for CT to do this check before we actually deploy. So this is really good for us to ensure that we follow the rules that we have. For instance, if you take a developer and then you actually, the developer is doing his magic, whatever it is, and pushes the code, then we trigger pull request environment. So we actually spin up a new environment, a new resource that the developer has invented, say, now we're going to have this resource. And then we spin it up and run different of tests, doing some automatic code reviews. We do manual code reviews of the PR and things like that. And also we run this simulation. How can this new resource affect the whole complex environment that we have? Which means that we actually can run the simulations on the fly, which is this is a really good way for us to ensure, and also to ensure that we are working as a whole. Every team do the same thing. A pipeline can be built up in the same way and things like that.
Yeah, Matthias, thanks for pointing that out, because that is something that we are trying to achieve with Forsidi, is that we're trying to tie these disparate islands together and to be able to contextualize your network and your AD and all your services and vulnerabilities, and to see the real impact, the real risk of risks in all these different places, but be able to look at that risk in a contextualized and combined view. And I think you also point out another important factor as well, is that by tying it into your CI/CD, you're also tying it together with your software development lifecycle to operations in a very, very natural way, to be able to approach this in a structural way. Yeah. Thanks so much, Matthias. But I think that the question that's on everyone's mind now is, now that we've pointed out all these challenges, all these risks, what can we do to harden our environment?
Yeah, that's a really good question. And in order to showcase that, I will switch over to the report that we have that you saw before, where we have the total risk exposure. We have the high value assets listed here, as we've gone through, and Andreas has shown us. We have a couple of segments here where we have TTC, the time to compromise. We have the risk matrix. We have a threat summary, and then on the bottom here, we have something called suggested mitigations, which is basically what the platform tells us to do in order to reduce risk. So let's dig into this. We can see here that we have a couple of things that we would have to take a look at. We have multi-factor authentication that we all know is something that would have to apply. And then using managed identity for the service principal is also something that would then make the system a little bit more secure and less risk exposed. I will take a look at another report that we have here and see that we have the correct one. Yeah, here's the one that we want to use. Sorry for that. Yeah, we have the same ones here on top, and then for the sake of this demo, we would like to talk a little bit about shutting down this SSH process that Andreas talked about before in the model. So in order to do this, we could basically, within the system, we could actually just select these two and apply the selected tuning and have the system resimulate as if we did these changes live. They will of course only be yeah, and then we just apply the tunings. And this means that we would then have these tunings applied to the digital twin and not live in the actual Azure environment, but only here. So doing that and resimulating, we would end up in this scenario that we have resimulated this, and having applied these two tunings, we can see that we had the initial simulation of 55% risk, and having turned that off, the SSH daemon, we now see that we are at 50% risk, which shows that we have decreased the risk exposure based on just applying these tunings. So having done that, yeah, sorry.
Can I just add a comment here, which is,
yeah, sure.
This is one of the great things. If you look from the operations part of view, you can actually have since it is a digital twin, so changes here that you apply or whatever it is, it's never affected the real environment. So what you can do is that you can actually just adding and try see how it affects. Can we mitigate these problems, or how will it affect? And also adding others resources, how will that be affecting the whole environment? So this is actually from an operations point of view, like adding firewalls or stopping the SSH or whatever it is actually then can see how it will be affected here. So it's good, truly good.
Yeah, thanks for pointing that out, Matthias. You're entirely right that we're doing this on a digital twin, so you can tweak it and do what if scenarios and play around with it before deploying.
Yeah, exactly. So let's take a look at how this panned out. Now that we've changed the risk exposure by turning off SSH, we can now go into the same row delete section that we had, the attack path. And now we can see that the one that Andreas talked about before, we had the SSH here. Now we can see that this segment is now gone and has been replaced by the second most likely attack step defined by the simulations. So how do we get started with all of this?
Before, can I
sure.
just ask Matthias, can you elaborate a little bit on how you use this at TRR?
Well, we have we have a stretch goal, if you can say it, to automate as much as we can, meaning that you can actually add simulations for different things and have them automated as well. So, and different kind of scenarios where the attacker location or if it is external, internal, or if it is just misconfigurations or whatever it is, we can actually run different simulations automatic. We've done it so a little bit, but we're aiming for doing from a lot of scenarios.
Excellent, thank you.
All right, thank you, Matthias. So moving forward, how do you get started doing this on your own environment? There is a couple of information segments that I would like to show you, which is basically the docs section on the Forseti homepage, which shows how we proceed in order to get ourselves up and running and starting to scan our environment. So first you need to create an app registration in Azure that is allowed to read the configuration, essentially a role that has the authority to do that. We will then have a couple of API keys ready from the portal that we will then use together with the Azure collector that we have on GitHub you would then use in order to pull down your configuration from Azure into a JSON file. After this step, there are essentially two ways of proceeding. Either you run the Azure parser locally and convert the JSON format into a proprietary SecuriCAD format that is then inserted into SecuriCAD, which would then represent the model that I showed you before. Or you could, the other way of doing this is using the upload feature now available, which basically means sending the JSON file directly into SecuriCAD and then having it do the conversion into a SecuriCAD model right there in the system.
Can I add another part of an alternative to the security or service principle is that it's actually possible to do the same with a virtual machine within Azure and instead use managed identities, which is also what we suggest in the critical path, that if you can use it, you should use it. The important thing is that the principle that you authenticate this program with has a global reader role on the subscription that you want to analyze, or subscriptions if you want to do several of them.
Great, thanks, Andreas. That's correct. So this was basically what we wanted to show you. Anders?
Yeah, thank you so much. And just to summarize here, what we've shown you is that with this new implementation for Azure, we can now extend the SecurityCAD functionality that we've had in the past to also include Azure, where we can show you that very quickly environments tend to get very, very complex, and it's hard to understand the associations and the implicit relationships and stuff like that. And that's where the SecurityCAD tool really comes into play, where by leveraging the power of AI is able to contextualize in a digital twin your environment using a number of data sources, everything from, like I mentioned previously, vulnerabilities to infrastructure to software vulnerabilities, and contextualize that, and then through AI to be able to quantify risks in each of those components and aggregate those in order to prioritize, to show you where are your greatest risks and how would an attacker try to leverage all available tools and assets of your environment to traverse it. And basically the attack paths then are ranked in order of how easy it is for an attacker, so that you can then distill this complexity down and understand how this attacker would traverse your network, and to be able to focus on those areas that are most at risk. And then the tool also helps you focus on which suggested mitigations will have most impact. And they're very, very targeted and actionable, so you can distill and understand where you need to place your resources. The webinar is now, we're moving over to the question section, and we have a question that is a follow-up question from earlier to elaborate a little bit more on how do you find these relationships step by step to predict the attacker's path? Is this based on checking lists of available vulnerabilities? Can you, Andreas, maybe you can elaborate a little bit more on that?
Sure. So, I mean, it's a combination of several things. In its essence, like some of the prerequisites are basically just the way that the resource works in itself. So the attacker needs to fulfill several, as a normal user, you would need to accomplish several steps for the end goal. For example, the Cosmos DB is a good example that you need access to this URL, for example, in order to access the data plane. And so I'm going to close the poll. And then on a valid endpoint, like if as a regular user, you're going to notice configuration that doesn't work unless you understand how you're actually going to use the service. So that's just the most basic part of it, is the RBAC permissions. When you have access to an account, you can accomplish certain things, and the attacker can configure the resource for its own infrastructure and get access to it. Another part is, of course, the vulnerability list. If you have vulnerabilities within your environment, then you can use known exploits for that to traverse further in the environment. And then lastly, you have the which is these sort of connections that we don't really see within your Azure environment, which are application-based. And that's where application insights come into play, that we can see this connection between them without having to know what kind of code is it actually running. But if we can deduce this association between these two services, and the attacker can compromise one of them and have full control of it, then we can sort of assume that he can do the worst to the resources that it's connected to as well. So yeah, it's a combination of several things.
Excellent, thank you, Andreas, and I hope that answers the question. Another question that we've gotten here, and I think that that Henrik, you may have touched on this earlier, but the question was, does this only work for Azure?
Yeah, so no, actually we have full support. We have support for Amazon Web Services, AWS, and also through our core line, we also have support for on-premise. So we can do on-premise and AWS and Azure as of today.
And combinations of them, right?
Yeah.
And then the last question here is there a get started guide where I can read more? And if I'm going to try to answer that, I think that was what we posted in the links in the chat, links to our documentation on forsidi.com, where there's a lot of documentation, and where it's we have get started guides. Maybe you want to elaborate more, Henrik.
Yeah, so as you can see here on the screen, we have the docs.forsidi.com, which is our the place where we store all the documentation. You see, for instance, we have AWS here, and the Azure and the SecureCAD Enterprise segment here that you could all take a look at, which is basically where we store all the data, the information. And then we have the Git repository that you would clone in order to acquire the Azure collector. It's basically just the Git repo, and there's some excellent step-by-step documentations here in order to get that set up. The Python scripts and all the stuff that you have to do in order to get this running is clearly and very excellently documented here. So read up on that, and yeah, that's basically the sources of information that we use.
Well, excellent. I think we're running a little bit short on time here to finish off as planned. We're drawing to an end, and we'd just like to invite you to follow Forsidi on LinkedIn or Forsidi's YouTube channel, but also check out Forsidi on the Azure Marketplace. And I'd lastly like to thank the speakers, and an extra thanks to Matthias, and thanks to TRR for this journey that we've been on together. Thank you very much.
Thank you.
Thank you, Matthias. That is all for today. Please stay safe. Thank you very much, and hope to see you soon. Take care.